Hello guys, in this quest we are going to look at some organic chemistry questions and answers. Please make sure you subscribe to this channel, turn on the notification button so that you'll be notified whenever we post a new video. Please also make sure that you share this video to your friends and colleagues who you think may need them. Now this video, I may as well make mistake. Learning is a process and everybody stay in the process. If you notice any mistake, please make sure to call my attention using the number below. Let's take question 1. Question 1 says the above reaction is known as. Now the reaction given to you is a reaction whereby acetone, this is acetone, is a ketone. Acetone is a ketone, or you can say propanone, reacts with the amine group and amine. Now these are amine functional group whereby it is attached to other compounds. It can be in the form of hydrazine, hydrazone and the rest. Okay, hydrazine, phenyl hydrazine, and also it can be in the form of semi-carbazide. So when these two react, what will be the product of the reaction? That is our major concern. Now if you look at this reaction very well, this is not hydration reaction. Now hydration means the use of water or the addition of water, H2O. Now is this a condensation reaction? If you look at this reaction very well, now you agree with me that this molecule combine with this to form a larger molecule with the elimination of water. This kind of reaction is known as condensation reaction. A reaction whereby a small molecule like water is eliminated or HCl is eliminated, while this other part of the nucleophile or whatsoever attaches to this group is known as what? Condensation reaction. For instance, if we say H3OH, this is an alcohol, plus let's say another H, this CH3. Now when these two come together to eliminate water, you see this forms CH3O CH3 plus what? H2O. This kind of reaction is called what? Condensation reaction. So the correct answer to this question is condensation reaction. Okay, condensation reaction is the correct answer to this question. Now let's take question 2. Now question 2 says the nucleophile is. What is a nucleophile? We said the nucleophile is an electron-rich species. Nucleophile, like I was saying, that a nucleophile is an electron-rich species, and because they are electron-rich species, they attack the positive parts of a compound, or in most cases they attack a part of the compound that will form a positive word charge. Okay, now which of the following is a nucleophile in this reaction? Now this is the substrate, this is what is reacting. Now this group here is called the nucleophile. Okay, so the correct answer is what? Correct answer, that is the nucleophile in this compound. Okay, option B is the correct answer. Now let's look at the next question. Okay, option B is the correct answer. This is it. Let's look at the next question. Now they say this nucleophile in the following reaction can be any of the following. Like I said, the following can be hydroxylamine, this is hydroxylamine, it can be hydrazine, this is hydrazine, and it can be phenyl hydrazine. Are we getting it? But it can be ammonia. Are we getting it now? So the correct answer is what? Ammonia. Ammonia is the correct answer. This nucleophile here can be any of the following except for ammonia. Okay, it can be ammonia. This is hydroxylamine. Hydroxylamine, and this is hydrazine, and this is phenyl hydrazine. In case you don't know, then this is ammonia. Okay, so this can be any of the following aside from ammonia. It can be phenyl hydrazine to form phenyl hydrazone as a product, it can be hydrazine to form hydrazone, and it can be hydroxylamine to form what? Ozyme. Okay, as the product. Maybe you should check it out in your textbook. Now let's continue with the next question. The next question says the reaction occurs in the presence of H plus, which is 2. Now what do you think will be the correct answer? What is the presence of H plus? Let's see what we have here. Now the correct answer is option B, which is to catalyze the reaction. Okay, it occurs in the presence of H plus in order to catalyze the reaction. So that is the correct answer. H plus catalyzes the reaction. Let's look at the next. Now the product can be used to identify the reactant carbonyl compound because now the product is usually a crystalline solid with sharp melting point. The product is usually a crystalline solid with a sharp melting point, and it is used to identify carbonyl compounds. Okay, and that makes option A the correct answer. Product is usually a crystalline solid with a sharp melting point. Let's continue. The next one says the complete hydrolysis of nitrite gives what? Now complete hydrolysis of nitrite will give an acid. It will give what? An acid. Complete hydrolysis of nitrite will give what? An acid. So the correct answer is option A. Whenever nitrite are hydrolyzed, the correct answer or the product that will be formed with what? Acid with another product. So complete hydrolysis of nitrite will give an acid. Okay, now let's continue. The next one says which of the following compound listed below has a sweet smell? Now the compounds that have sweet smells are the esters. The esters have sweet smell. So any of the compound that is an ester should be the correct answer. Now what are the esters? They have the general formula of ROC, double bond O, then OR. Where R is an alkyl group. Are we getting it now? Now R may be differ from R prime, or R may be the same with what? R prime. Now this will say the alkyl group, let's say this is R prime. Okay, arrow here, this alkyl group may be the same with this and it may be differ. For instance, if we have CH3, C double bond O, CH3, you discover that the alkyl group here is the same with the alkyl group here. Okay, so the arrow and arrow prime in this case are what? The same. But in a situation where you have something like this, CH3, C double bond O, O, then CH2, CH3. If you look at this very well, arrow is what? Is different from arrow prime. Hence, the esters, they have the general formula of this, where arrow can be the same with arrow prime, or arrow can be different from arrow prime. And which of the following do you think has the ester functional group here? Now if I want to draw this, I will say this is arrow COO arrow. So any compound that have this COO group is the correct answer to that question. Okay, now the COO group, after the COO you must have another arrow group. Now you have the carboxylic acid. After COO group, what do you have? H. This one does not have COO, this does not have COO, but this one is the correct answer because it has COO, then it has another alkyl group. So this is the ester functional group, which everybody should know that is ester. So the correct answer to that question is option D, correct answer. Let's look at the next. Now the next question says the IUPAC name of the following compound, or the compound written below has the following IUPAC name, whichever way you want to put it. The IUPAC name of the compound whose structure is written here is. Now first of all you have to number. Now from what direction do you think our numbering will come from? This will be number 1, this will be number 2, this will be number 3, this will be number 4, and this will be number 5. Okay, so the name of this compound will be, we have to name the alkene functional group first, but before then, what is the longest continuous chain? How many carbon does it have? It has 5 carbon. So you say this is pent because it has 5 carbon. Now at what position is the double bond? Position number 3. So we say pen 3 in. Now at what position is the ketone functional group? Because this ketone functional group is the prevalent functional group here, and it usually ends with ONE, which is on. So this is pen 3 in and what? 2 ketone because it's at position number 2. So that is the correct answer. The correct answer to that question is pen 3 2 on, which is option B. Pen 3 2 on. Now let's try another question. Typically, aldehydes are more reactive than ketone because now look at the aldehyde functional group. They are arrow, C, double bond O, and H. Then the ketone, arrow, C, double bond O, and arrow. Now, if you look at these two functional groups, this is hydrogen. It's not sterically hindered, while this is another alkyl group, which maybe was sterically hindered. So the first reason is because aldehydes they have better leaving group. That is not the reason. Now B, aldehydes are less sterically hindered. That is true. Aldehydes are less sterically hindered. Steric hindrance is like having things that surround you that will prevent somebody or something from reacting with you. For instance, let's assume this is a guy, or let's say this is a girl, okay? And this girl has so many friends around her. Now, if a guy, let's say this is a guy, if the guy wants to approach this girl, because of the so many friends, it will be very, very difficult to approach her, most especially if the friends, they have very stupid characters, okay? So in that case, it will be very, very difficult. But if the girl is standing alone, let's say she's standing alone with, let's say, a friend that is just standing by this side, the guy can easily approach her. So aldehydes are less sterically hindered than ketone. This is a reason. Now, the CO group of ketone is attached to a more electron donating group. Now, that is true. The CO of ketones are attached to a more electron donating group, which is this arrow group here. And the more electron it donates here, the more stabilize this carbon bond is, and the more stabilized it is, this is the functional group, okay? This is where reaction take place. The more electrons that this group donates to this, the more stabilized it is. And when something is stabilized, it doesn't usually mix with people, doesn't react with anything, okay? So that is another reason. And so the correct answer is what? Option D, which is B and C. Aldehydes are less sterically hindered, and then CO group of ketone is attached to a more electron donating group. The more electron that this one donates, it's just like you have your parents supplying you food every time. Supplying you food, it will be very difficult for you to go and mingle with people to beg food from or to ask of anything from, okay? The reason why most they react is so that they will become stable. So if you're already stable, there is no need of you reacting. So this group here donates more electrons to this word, to this carbon here, and because of that donation, this group here, carbonyl group, becomes more stable. And when it is more stable, what happens to it? It doesn't easily react. So that is one of the reasons why the aldehydes are more reactive. For this particular case, it can easily react. So the correct answer is option D, which is B and C at this point in time. So let's look at the next question. The next says the CO bond in aldehyde and ketone is. Now this question seems somehow confusing at the same time, because the CO bond in aldehydes and ketones, they are covalent in character, but the percentage is somehow, if I will go with anyone at all, I should go with 70% covalent in character, because it is more covalent than it is ionic. So 70% covalent in character, that's what I will go by. But you could still make more research to actually choose or to get the particular answer. I've made research, I've searched online and everywhere, and I couldn't get it. Maybe it was given by the lecturer in his notes, definitely. So that is that. Now let's look at the next. Next question says the following synthetic method can be employed to produce carboxylic acid, except the following synthetic method can be employed to produce carboxylic acid, except. Now we have the oxidation of primary alcohol. That is true. When primary alcohols are oxidized, they give aldehyde, okay? Now when these aldehydes are further oxidized, they will give the carboxylic acid. Now, oxidation of tertiary alcohol. Tertiary alcohols are not readily oxidized. Hydrolysis of esters. Now, when esters are hydrolyzed plus H2, they give what? The carboxylic acid. For now, the reaction conditions are not really important. Now we have hydrolysis of nitrite. When nitrite are hydrolyzed also, they give the carboxylic acids. Okay, so the correct answer is oxidation of third degree alcohol. That is not employed for the preparation of alcohol, of carboxylic acid. That is not employed for the preparation of carboxylic acid. Let's continue. The next says, which of these following can be used to convert acid to acid chloride? Now, if you want to convert acid to acid chloride, you react with thionyl chloride. Okay, and when you react with thionyl chloride, it will give you the acid chloride, which is C double bond OCl plus what? SO2 plus HCl. This will be the product of the reaction. So the correct answer is option D, which is thionyl chloride. This is thionyl chloride. When thionyl chloride reacts with acid, they give the acid chloride, sulfur dioxide, and HCl. Now let's continue. The next one says dash gives effervescent with aqueous sodium hydrogen triazocarbonate. Now this is a test for the carboxylic acid. This is a test for the carboxylic acid. When they react with this, they give what? Effervescence. Okay, they give effervescence. So any of the option here that is a carboxylic acid should serve as the correct answer, and the carboxylic acid here is option B, which is the propanoic acid, and that makes option B the correct answer to this question. Let's continue. Now, the increasing order of reactivity of the derivative of carboxylic acid is. Now, can you guess the answer to this question? The increasing order of the reactivity of the derivative of carboxylic acid is as follows. What do you think will be the correct answer? Now, the higher the leaving group, or the higher the ability of the group attached to leave, the higher the reactivity. Now, in order of leaving group, in order of increasing leaving group, the Cl bond is greater than the anhydride, which are the acid anhydride. Okay, let's say acid anhydride, and that one is greater than the ORO of the ester, which is greater than the OH of the acid, and greater than the what? NH2 of the amine. So the Cl group leaves faster compared to the acid anhydride, compared to the ORO of the ester, compared to the OH of the acid, and NH2. So the correct answer to this question will be the one in such a way that this one will be what? Will be least, because the question says the increasing order of the reactivity of the derivative of carboxylic acid is as follows. Increasing order. So you go from the one that is less reactive. Now in this case, these groups are least reactive. Okay, these groups are least what? Reactive. Why? Because they are not easily substituted. Okay, these groups are least reactive because they are not easily substituted. They are not good leaving group. Okay, so the correct answer to this question will be option C, which states that this is least reactive compared to this, which is least reactive compared to this, which is least reactive compared to this, which is least reactive compared to this. Now this is more reactive. Why? Because it has a good leaving group. This is more reactive. Why? Because it has a good what? Leaving group. Then followed by this, followed by this, followed by this. The NH2 leaving group does not easily what? Leave, and hence it's very, very what? Difficult for it to react. Let's look at the next. The next question says the main product of the reaction between this and this are, what will be the main product? Now, whenever you are given any question like this, I usually say this reaction is called ozonolysis. Okay, ozonolysis. Now, ozonolysis means the addition of ozone to form a carbonyl compound. Addition of ozone to the double bond of alkane to form a carbonyl functional group, which can either be an aldehyde or a ketone. So when this reacts, one way I like to look at this is divide this into two. So you have CH3CH double bond, then the other one is what? You have double bond C bracket CH3 and what, to then add oxygen to each of the ends of this double bond. So this will give you CH3CO, which is this, and then C. If I want to write this again, becomes CH3 bracket 3 C double bond what, O. So the correct answer is CH3CH then double bond O and CH3 bracket 3 C double bond what, O. And that is option B. Now it's very easy. All you need to do, divide this into two. That will give you either an aldehyde or a ketone. Now in this case, it gave you an aldehyde and what, a ketone. This group here is a ketone functional group, which is C bracket CH3 to C double bond O. So this is a ketone and this is an aldehyde. Why is it a ketone? This is CH3, this is C double bond O, CH3. This is a ketone. Why this other one here is CH3, C double bond O and what, H. This is an aldehyde. So the correct answer to that question is option B. Option B. Let's look at the next. Next question says that gives a yellow precipitate with sodium hydroxide and I2 on heating. It's called the iodoform test. Now the iodoform test usually use a methyl ketone or acetaldehyde. A methyl ketone or acetaldehyde. Now what is a methyl ketone? A methyl ketone is any ketone that has a CH3 group attached to the carbonyl group. Now if you look at acetaldehyde also, it has the CH3 group attached to this carbonyl group. So anyone that has CH3 group attached to the carbonyl group can undergo the iodoform reaction, which is also called the haloform reaction. Okay, which is also called the haloform reaction. So which of them do you think will be the correct answer? This is already acetaldehyde, which is CH3CH. If I want to write it out, it becomes CH3 C double bond O and H. This one has the CH3 group attached to this. So this will be the correct answer, which is option D. Okay, so whenever you see any group like this, for instance, if they give you this particular group, can it undergoes iodoform test? Yes. Why? Because this CH3 group is attached to the carbonyl group, which is a methyl ketone. However, if you are given CH3 CH2 C double bond O CH2 CH3, this does not have a methyl ketone, hence it cannot undergo the iodoform test. Now iodoform test is one form of the haloform reaction. Now you have is one form of the haloform reaction. Okay, now you have other tests like we have other tests like bromoform and what, chloroform, which is responsible for the hospital smell. Bromoform or chloroform, which is responsible for the hospital smell. So whenever acetaldehyde gives a yellow precipitate, or whenever acetaldehyde is heated with iodine or sodium hydroxide in iodine, the product is usually a yellow precipitate. So anything that has a methyl aldehyde or a methyl ketone should form iodoform test or the haloform reaction. Let's look at the next. Now, aldehyde reacts with solution of silver nitrate in excess sodium hydroxide and O2 to form a silver mirror. Okay, this will form a silver mirror. That is the correct answer to that question, to form a silver mirror. Let's look at the next. Ketones are oxidized by chromic acid to give no reactions. When ketones are oxidized by chromic acid, they give no what? Reaction. Let's look at the next. They give no reaction. Okay, they give no reaction. The next questions. Now, predict the major product obtained from the following reaction. What will be the major product obtained from the following reaction? Now, first of all, when this react with this, the amine group will attach here, replace this oxygen to form the imine. Okay, to form a nitride group here. So this will form something like this: CH3 C to form a double bond, then NH, and then CH2 CH3. Are we getting it now? So when this now undergoes hydrogenation, this will now form this. Hydrogenation means that this group will be broken down. So here will become what? NH. One of the hydrogen comes here. So we'll have CH2 and CH3. This is called reductive what? Amination. First of all, aminate it by adding the amine group to here to form an imine. Then from there, reduce it by addition of what? H2. So the correct answer to this question is option A. Option A is the correct answer to this question. Option A, which is that reductive amination. You can check it out. Okay. Now the next question says, which of the following compound with the same molecular weight has the highest boiling point? Now, compounds of the same molecular weight, the one that have the highest boiling point is the one that can have a higher hydrogen bonding. If you look at pentanol, pentanol is CH3, penta1 or CH2, 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 and OH. Now the next one is CH3, CH2, CH2, and then C double bond O and OH. This is butanoic. Then we have CH3, CH2, 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 CHO. Now this is pentanal. This is butanoic, and this is penta1O. Now among these, which do you think can easily form hydrogen bonding? Now this one can form a higher hydrogen bond with itself, and hence it require a higher melting boiling point. Are we getting it? Now the order of boiling point, the aldehydes, order of boiling point, the aldehydes are usually less than the alcohol, which are less than the acid. So the acids have a higher boiling point compared to the alcohol, which have a higher boiling point compared to the aldehyde. So in order, the one that have the highest boiling point of the same molecular weight is butanoic acid. Okay, butanoic acid is the correct answer to that question. Butanoic acid, which is option B. So that is it for this particular lecture. Please make sure you subscribe to the channel, turn on the notification button so that you'll be notified whenever we post a new video. Thank you for your time, and God bless.